Okay, so the arrangement of the gear train you can see where two shafts A and B are coaxial, and gear C is rigidly mounted on the shaft A, and a compound gear, that is DE, with the C and integral with the G, and D has 20 teeth is given, and gear with the C and E and has 35 teeth, and gears with an internal gear G, and gear G is fixed and is concentric with the shaft axis, and the compound gear, that is DE, is mounted on a pin which projects from an arm keyed to the shaft B, and you have to sketch this arrangement, and the arrangement is like this. And you have to find the number of the teeth on the internal gear G, and assuming that all the gears have the same module, and if shaft A rotates at 110 rpm, you have to find the shaft speed B. Okay, so from this, how to calculate the number of teeth on G? Anyone?
Sir, DG equal to, we can add all, sir. DC and plus DD, DD plus DE.
Okay, so what you can do is that the radius can be nothing but Tg will be Tc plus Td plus T. So the diameter of all the things, what you told, so yes, it is correct. So you have to add things. So finally you will be getting 50, 20 and 35 already given. That is for C, D and E already given in the question. So just adding this, we will get 105. So that will be nothing but the number of teeth on G. And table of motion will be going like this. So if you fix the arm, so next we give the motion to the C, and when you give motion to C, it becomes +1, and then compound gear D, E will be opposite direction because that is meshing with the external part. So when C is connected to D, then D and E are compound wheels, so you will get minus TC by TD. And similarly, when the compound wheel again disconnected with the G, this will be internal. E to G, you can see it is an internal gearing, so the direction will be same. So it is again minus is written here, so minus Tc by Td coming from here into Te by Tg. Then multiply by x, add y, so you get the equations like this in the form of x and y. And when you solve this with the initial condition which is given there, so gear G is fixed. So G is fixed means the last one here, G, this one, y minus x into Tc by Td into T by Tg, this entire thing becomes 0. So from this you get the equation as y minus 5 by 6 x equal to 0. Okay, then from one you get one equation from here. Then with the given another condition, since the gear C is rigidly mounted on shaft A, therefore the speed of gear C and shaft A is nothing but same. So we get the speed of shaft A is nothing but 110 rpm. So x plus y is equal to 100, and you get x as 60 and y as 60. Okay, x as 16, y as 50. So the shaft of this speed of the shaft B, that will be speed of the arm, and that will be plus y. So y, what is y here? Directly given 50. So 50 rpm anti-clockwise direction. You got this answer? Hello? You got this answer or no? Hello?
Got, sir.
Okay. So this type of problem was solved in the last few classes. So next we'll go with the torque. Last class I had explained you regarding the torque. That is the torque in epicyclic gear train, where input and output torque can be made equal, and by taking T1 omega 1 equal to T2 omega 2, that will be equal to 0. Okay. So this concept will be using next to solve the next step of problem. The first step, whatever you have done till now, that will be same. Only the last part there will be torque given in the question. Okay. So this is next question. You can see in this an epicyclic gear train is shown to you. You can see in the figure, and the pinion A has 15 teeth at the inside part. You can see at the center, and is rigidly fixed to the motor shaft. So the A is fixed to the motor shaft, and the wheel B, which is connected to A there, you can see in the figure, that is having 20 teeth. Okay, and then and gears with A there, and also with an annular fixed wheel E. So you can see the figure there. That B is also connected with A and also with the E outer part. Then pinion C has 15 teeth and is integral with B. Okay, and BAC being a compound gear wheel, automatically there will be compound one, this one. So gear C meshes with annular wheel D. So you can see C is connected with the D here, that is inside part, and which is key to the machine shaft here, and the arm rotates about the same shaft on which A is fixed and carries the compound wheel BC. Next, if the motor runs at 1000 rpm, you have to find the speed of the machine shaft. Okay, and you find the torque exerted on the machine shaft if the motor develops a torque of 100 Newton meter. So these are the initial conditions given. So first you need to first find out the speed whatever is given, table of motion, and then calculate the torque also. So if the motor is having a torque of 100 Newton meter, you have to find out the torque for the machine shaft. Okay, so can you tell now what is this given data? Motor runs at 1000 rpm means what is, which speed is given? Anyone? Read the question correctly. Anyone? The in question it is specified the motor runs at 1000 rpm. What is given? Can you tell?
Sir, NA.
What is this 1000 rpm? It is NA, correct. Okay, so you have to read the question correctly. See, pinion A has 15 teeth and rigidly fixed to the motor shaft. Here only the first sentence only they are given. So we should understand which is given there. So this is nothing but for this one A. So NA is given 1000 rpm and other number of teeth is given. So TA is given as 15, TB is given as 20, TC is given as 15. Then torque given by the motor, that is for pinion A, is 100 Newton meters given there. And from the relation, so D equal to dA plus 2 times of dB, and dd will be equal to dE minus dB minus dC. So go through the figure here, and from there you can understand how the, if you want to get the radius, you have to use this relation. So from there you will be getting T equal to TA plus 2 times of TB. So 15 into 2, 15 plus 2 into 20, you get 55, and TD you get TE minus of TB minus TC, and substituting that you get 50. Okay, so check this out, 50 and 50, 55 and 50. Then table of motion will be same as it is what you have done in the previous method, same thing. So first we will fix the arm. This is the arm here, so arm will make it fixed. So arm is fixed, and which you have to give +1 revolution, that you need to see. So pinion A rotates rotated through +1 revolution, so we give motion to A. So pinion A we give +1 revolution. So here this is given +1 revolution. Next, once pinion is given +1, then it is kind of meshing with compound wheel B and C. So opposite direction, external gearing here. So it will be in this, if it is anti-clockwise, this becomes clockwise, and this will also be clockwise. Okay, so this all will be same direction now. This all are meshing internally, other two gears. So all will be nothing but opposite direction, that of A. Okay, so compound wheel will be TA by minus TA by TB, then wheel D connected from the compound wheel. So from there it is minus TA by TB into TC by TD. Again this will continue from this one up to to wheel E. Wheel B from how much? It is TA by TB from here only. Now into TB by TE. Okay. So TB and TB get cancelled. So left out with minus TA by TE. So go step by step. You will be getting this relation. And next step, you know it, multiply by x and add y. You get this equation at the last. Then you find out x and y using this relation given in the condition. So you know that NA is given 1000 RPM. Then speed here it is for A is what? X plus y. So x plus y is 1000. So this condition will be getting. Then wheel E has made fixed. So wheel E fixed means this part. This will be fixed. So y minus x into TA by TE also equal to 0. So for using this relation, substituting the values in equation 1 and 2, you get x equal to 786 and y equal to 214. And if you want to calculate now the speed of D, so speed of machine shaft is nothing but the speed of the wheel D. Okay. So y minus x into TA by TB into TC by TD. Substitute all the values. You get 37.15 RPM. So 37.15 RPM and take clockwise direction. Okay. Next step, after this he has told to calculate the torque exerted on the machine shaft. So just you have to use this relation what we had discussed in the last class. So that will be equal to nothing but torque developed by the motor into angular speed of the motor, that is T1 omega 1 equal to T2 omega 2, same thing. Okay. So 100 into omega 1 A equal to torque exerted on the machine shaft into omega D. So this is already given. Okay. So you know the speed for A, this is known to you. So you can find out the torque exerted on the machine shaft, this you can calculate. Even speed you got from for the D also in the last case here. So speed of D is already known to you. So it will be nothing but 100 into omega A by omega D. So omega and NA will be proportional, nothing but 2 pi n by 60. So both anyway it is ratio. So omega A can be written as NA and omega D can be taken as ND. So substituting the value, you get the torque exerted on the machine shaft as 2692 Newton meter. Okay. So go through this, solve it. Okay. So next, an epicyclic gear train consists of a sun wheel and a stationary internal wheel, gear E, and 3 identical planet wheels P, carried by a star-shaped planet carrier C. Then the size of different tooth wheels such that the planet carrier C rotates 1/5 of the speed that of sun wheel S, and minimum number of teeth on any wheel is 16, and the driving torque on the sun wheel is 100 Newton meter. You have to determine the number of teeth on the different wheels of the train and torque necessary to keep the internal gear stationary. So it is similar to the problem what we already solved, this sun and planet type of problem. Okay, I think you can solve by yourself also. So you can try this. Okay, so same conditions you have to use what you have to use for the previous type of problem for planet and sun type of system. So here we consider again arm as fixed, that is a planet carrier C, and give +1 revolution to the sun wheel. So same condition. So planet C again arm becomes 0 and sun wheel is given +1 revolution, and other all things will be again opposite direction. So planet all will be nothing but sun to the planet, so minus Ts by Tp, and internal gear E outside will be Ts by Tp by Tp by T. So Tp and Tp get cancelled. So we'll have taught with minus Ts by T, same thing. So directly we'll be getting, if you multiply x and plus y, so you get y here, C, and sun will you get x plus y, then P you get y in minus x into Ts by Tp, and E you get y minus x into Ts by T. Then after solving this table, next go with the condition. So same conditions there. So when the sun wheel makes 5 revolution, the planet carrier makes 1 revolution. Okay. So if y is equal to 1, then x plus y becomes 5. Means for the sun it is 5 revolution. So same condition from here. So we take the condition for fixed arm and then for sun wheel S. Okay. So y becomes 1 and x plus y equal to 5. So from there you can get x and y value. So y if it is 1, x automatic x becomes 4. And if gear E is stationary given there, so this condition becomes 0. And from this the ratio given here, that is the minimum number of teeth should be taken as 16. Okay. So if since the minimum number of teeth on any wheel is 16, therefore we take the number of teeth on the sun wheel as 16, that is Ts equal to 16. So if you take the ratio, that is T equal to 4 times of Ts, that ratio we will be getting from this condition, and you get if Ts is 16, you get T as 64. Okay. And from the ratio of the pitch circle diameter for S and P and E, you get ds plus 2 times of dp equal to de. Okay. So from this relation you get Ts plus 2 times of Tp equal to Te. So from there you can calculate the number of teeth for P also. So get 24. And the last part, the torque which is there. So torque will be nothing but will be equal to torque on C will be equal to torque on S equal to C. So 100 into omega S equal to 100 torque on C into omega C. So torque on C will be 100 into omega S by omega C. So substitute the value already known to you. So this ratio is nothing but 5. So here to get 500, and the torque necessary to keep the internal gear stationary will be nothing but 500 minus 100. So that will be left out with 400 Newton meter. So like this you can solve the problem. So same type of condition what we are solved for previous type of problem, same condition you can use.